Now let's look at solving inequalities graphically. We've solved equations graphically, and what we did was we took the left-hand side and graphed it, and the right-hand side and graphed it as separate equations. So y equals 3x minus 4 and y equals 8. We've done that in Desmos quite a few times this term. Here I've just provided the graph that I got in Desmos when I did it. Notice you can tell which one's which because y equals 8 is a horizontal line, and then y equals 3x minus 4 is this red line that is diagonal with a slope of 3 and a y-intercept of -4. So there are two graphs, and we actually can see where they intersect. And that's the first thing, is look for where they intersect. Now, beyond that, to solve the inequality, we're not interested in where it's equal. We're interested in when the left-hand side is less than the right-hand side. And what we want to do is think about, what are we graphing here? The left-hand and the right-hand side are both being graphed by y. Y equals 3x minus 4 and y equals 8. So what we care about here are the y values. Where are the y values on the left graph less than the y values on the right graph? Now, in terms of looking at the graph, we want to think about how the y values are in the vertical component. So we can interpret y values being less than other y values in terms of two graphs by thinking about which graph is below the other one. Less than means it would be below in terms of the vertical components. So when we look at where is the y equals 3x minus 4 lower than y equals 8, in other words, where is the diagonal line lower than the horizontal line, that would be in through here, the area I've just highlighted. So it would be that part of the graph. Now our solutions are going to be the x values there. So keep in mind that we're going to be looking at the x values in that region. So when we kind of go down and imagine where we are on the x-axis or go up, what we have is that 4 is our boundary for where that's going to happen. And then we're going to be shading all the way to the left. So our solutions for this inequality, or our solution set, would be an interval of numbers, just like we've seen when we solve algebraically, but it would be from -infinity to 4, the intersection point, but we're not including 4 because this inequality does not have an equals in it. So again, what we're looking at are comparing the y values of the two graphs based on the inequality we see in the problem. So in this case, we have a less than. So we want the graph for the left-hand side of the equation to be lower than the graph for the right-hand side. So in this case, that means the diagonal graph, where is it lower or below the horizontal line? Now we can check our answer here by just thinking about what we would get if we were solving algebraically. So 3x minus 4 is less than 8, 3x is less than 12 by adding 4 to both sides, and x, when I divide by 3, is less than 4. That matches what we just saw for our solution set. You could also check the values by individually putting a point in on the left-hand side of my boundary and on the right-hand side of my boundary, just like we did before, and check to see if something that's in the solution set gives a true statement and something that's not in the solution set gives a false statement, would be another way to check. So as we can see, this solution set makes sense. Let's look at some more examples.